Now, achieving the energy transition to help reverse climate change is a huge challenge. Standard gas technologies, SG100 non-burn advanced thermal treatment technology addresses this by processing vast amounts of unrecyclable CO2-producing waste into low or no carbon energy and carbon-removing biochar. Well, joining me in the studio is David Whitmarsh, who is the Chief Executive of Standard Gas, and also Richard Jackson, the Director for Carbon and Product Development. To both of you, welcome.
Good morning. Pleased to be here.
I'm going to start with you first, David. SG100, what is it and how does it work?
Yeah, so what we do, we take residual non-recyclable waste that's currently heading towards landfill or incineration. We feed that into one of our vessels, we heat it up to very high temperatures, and a process of volatilization occurs where we separate the gas and the solid. We end up with two products. The first is a very clean, energy-rich syngas that can be used to replace anything that natural gas is used for currently, and a carbon char, which if we can sequester that carbon char into construction products and agricultural products, we can make the energy that we produce, as you said before, low carbon or even carbon negative.
So Richard, what makes this technology transformational?
Well, there are two parts to that really. The first is the fact that we don't burn waste. We don't use oxygen to break that substance down, and that preserves most of the energy within it. So we produce from that a carbon-rich, highly energetic gas, some of which powers the whole unit, but a vast amount of it we could use elsewhere. You can replace fossil natural gas with it in industrial settings. And then the second thing we produce is a carbon-removing char.
Yeah, okay, so the carbon removal is an element of this technology. Why is that so important?
Well, not only do we reduce our emissions, but we actually also remove them to get to net zero. Let's remember that carbon was in waste, and if that waste was biogenic, meaning if it was paper or cardboard or wood, then that was derived from atmospheric carbon. It comes through to the waste, then we can transform it into a carbon that can be buried, and that reverses the whole route.
Okay, so David, you're commissioning your first SG100 plant. How will you be working towards expanding those sites across the UK and worldwide in the future?
Absolutely. So the commissioning of the first plant should complete in the later part of this year. We've already identified suitable sites across the UK and Northern Europe where we can deploy up to 30 of our units. Each unit will remove about 50,000 tonnes of waste, so we'll be contributing significantly to diverting waste away from landfill and incineration and capturing the carbon that we've been talking about here. The first sites here in the UK, 4 sites across the country that will allow us to deploy 10 units within the next 2 years, and those will be providing power, heat and electricity into a number of different uses.
And just looking to the future benefits of the technology, just tell us a little bit more about that.
So I think there's a real need for low and no carbon power supplies and heat supplies that can provide 24-hour, 7-day-a-week energy supply. And I think that's one of the things that we can do specifically with the gas, the molecules that we produce. I think there's plenty of innovation around renewable electricity, but around renewable molecules, renewable gas, there's still a lot of development needed, and that's, I think, where this standard gas technology can really feed into it.
Yeah, I mean, the main thing here is that we've got enough carbon out of the ground already. We don't want to keep extracting more and more. We need to start thinking, where can we get replacements for those, lubricants, plastics, those sort of molecule feedstocks. And this sort of technology will then, I think, in coming years, really give a sort of an opportunity to source those carbon molecule atoms from somewhere else.
Okay. Richard, David, thank you both very much indeed. Thank you.